Hi, are the solutions to the practice test for the quiz for chapter 12, sections 4 through 5, or 4 and 5. It includes 12.2 and 12.3. That's okay, they can't hear it anyway. All right, so number 1, I'm going to zoom in a little bit. Find the sum if there is one of this. It's an infinite geometric series, you can tell because there's an infinity sign on the top. Now the formulas are going to be on top of the page, but they're not going to be identified, so you have to know which one to use. This one, the sum of the infinite series, is the first term divided by 1 minus r. R is easy to find. It's always the part that's raised to the exponent, where n is the exponent, so r is equal to 2/5. The first term, a sub 1, well, we need to calculate that. Put in 1, because that's where the first term begins, at n equals 1. Put in 1, 1 minus 1 in the exponent is 0. 2/5 to 0 power is equal to 1. 1 times 6 is 6. That's all we need to do the formula. So the sum of the infinite series is 6 divided by 1 minus 2/5. Plug that in your calculator. Figure it out, and the answer should be 10. For number 2, find the sum of this series. Now, if you notice, this one, it ends where n equals 50. So this isn't an infinite series, so we're going to have to use the sum of a geometric series. That formula's a little bit more complicated, so to do that formula, put it right here. We need the first term, the r, n, and then 1 minus r in the denominator. So first term, I starts at 1, put in 1. 1 minus 1 is 0, 1/3 of 0 power is 1. So a sub 1 is just 15. R is part raised to the exponent, so that's 1/3. And n, that's the number of terms we're adding together. Since it starts at 1 and goes up to 50, that's 50 terms. All these need to be put in the formula. When you do that, the sum of the first 50 terms is going to equal first term 15 times 1 minus r, which is 1/3 to the 50th power. All that divided by 1 minus r, which is 1/3. Okay, be super careful putting this into your calculator. Make sure when you're done, you end up with something very close to 22.5. I suggest putting the 1/3 to the 50th power in first. You get a good approximation for that. All right, for number 3, find the sum if there is one. The summation as n goes from 1 to infinity of 3 times 7/5 to the n minus 1. Well, since it's an infinite series, because n goes to infinity, we need r. And since r is actually greater than 1, that means there's no sum. Okay, so it would actually go off in infinity. So for number 3, there's just no sum. Okay, watch for that on the test. There'll probably one just like that. Okay, number 4. It's another infinite series. You can tell by the dots right there. It's infinite. It means it goes on forever. So we can use that nice formula. The sum is equal to the first term divided by 1 minus r. Well, the first term is the first term listed right there, 5. R is how you get from one term to the next. So look at the fractions. From 10 to 20, multiply by 2. From 3 to 9, I multiply by 3. So a sub 1 equals 5 and r equals 3. Put all that into that nice formula right here. The sum is equal to 5 divided by 1 minus 2/3. 1 minus 2/3 is 1/3. 1/3. Okay, 5 divided by 1/3 ends up being 15. All right. Number 6. Changes to a fraction lowest terms. All right, we're just going to do the shortcut. The whole number part is 4. The part that repeats 423, 423, 423, put that in the numerator. I'm sorry, 243, 243, 243. So 243 in the numerator. Need just as many 9s in the denominator. Okay, now we can actually reduce that. 243 over 999 is going to reduce to 4. and 9 over 37. Okay, so number 6 is 4 and 9 over 37. Okay, we better do number 5. On number 5, the sum goes from 1 to 15. So this isn't an infinite, it's a finite geometric series, so we have to use the log formula. The first term, 1 minus r to the n over 1 minus r. What's neat about this is the first term when I put in 1, wound up being just 5. R is 2, and n is where we stop at 15. Plug all that into this formula right here. The sum of the first 15 terms is equal to 5 times 1 minus 2 to the 15th power over 1 minus 2. All right, that's going to be a nice big number. When you put that all in your calculator, you get 163,835. All right, I just have 3 problems left. I'm going to put them all in this video. See if we can do that. Number 7, what are the first 4 terms of the sequence? The initial value, a sub 1 is -7. They have the recursive formula right here. So a sub n equals the term before it plus 2 times n. A sub 1 equals -7. A sub 2 equals -7 plus 2 times n. So for a sub 2, n is equal to 2. So -7 plus 4 is -3. A sub 3, take the term before it, -3 plus 2 times n, and for that, n is equal to 3. Okay, -3 plus 6 is 3. All right, keep going. For a sub 4, now n is equal to 4. The term before it is equal to 3. So 3 plus 2 times 3, that would be 9. So not what I got last time. Oh, n is 4. There we go. N is equal to 4. So 3 times 2 times 4 is 11. There we go. So our first terms are -7, -3, 5, and 11. Just like that. Okay. Number 8. The recursive rule. You need to start with the first initial term is 7. A sub n. How do you get from one term to the next? On this one, from 7 to 21, I multiply by 3. From 21 to 63, multiply by 3. So apparently, I just multiply 3 times the term before it, n minus 1. Okay. So that's your answer. Make sure you include both the initial term and the rule to get the next term. All right. Now, number 9, the very last one. All we need to do is find the first 3 iterates of this. We start by putting in 5. F of 5 equals 2 times 5 minus 3 equals 7. That's x sub 1. X sub 2. Now we put the 7 in. So 2 times 7 minus 3. Oops. It's 11. For x sub 3, put in 11. 2 times 11 minus 3 is 19. Okay, so your first 3 terms, 7, 11, and 19. Okay. All right, I hope this helps. Talk to you later. Bye.